What's happening, y'all? Pastic back. Doing another one of these here calculus videos for you. We are still reviewing trigonometry in the unit circle, and in this example, they want to find the coordinates of the point 1, 0 under a rotation of 70 degrees. So first off, we'll start with some notation. This means a rotation of 70 degrees of the point 1, 0, and we are looking for the coordinates. So we always want to start here. This is our initial ray at 1, 0, and that's 0 degrees, also 0 radians. And we want to rotate 70 degrees. So it seems to me like that would be like somewhere up here, about 70 degrees from here to here. Well, we learned last time that the x coordinate can be the cosine of the rotation, and the y coordinate can be the sine of the rotation. So this is going to be cosine of 70 degrees and sine of 70 degrees. That should be how we find the coordinates of this point. Well, I don't know what those values are. Those aren't nice angles to deal with. They're not 30, 60, or 45, or 90, or anything like that. So we're just going to use our calculator. So here I am on my calculator. The first thing I want to do is, since we are inputting degrees into our functions, into our sine and cosine function, I'm going to go to mode, and I'm going to make sure that I have turned on degrees. It's the fourth one down. Make sure degrees is highlighted as it currently is. Hit enter on it if it's not. And we'll head back to our problem just after we type in cosine of 70 and sine of 70. And as you can see, I've already done that. So cosine is about 0.342 and sine is about 0.940. So let's get those numbers written down. So 0.342 and 0.940. 0.342 and 0.940. Well, how do you know if you did this right? Well, there's really only kind of one way to sort of like eyeball it and check it. Just think about if it makes sense or not. So this would be right here about a half, right? Because remember, this whole distance here is 1. So that'd be about a half, so it makes sense that the x coordinate is a little less than a half, 0.342. And if you look at this right here, this is all the way up here, and we know the coordinates of this point are 0, 1, so this y coordinate should be just less than 1, which it is, 0.940. Sweet. So the next one is rotations of multiples of 90. These are supposed to be on the easier side when we do these problems. So always, again, we start at our initial ray, and this thing is messing with me, so we go over here like this, rotate 90 degrees, just like that. I don't know why it's dotted. I don't know what's happening. This point is 0, 1, that's why it's dotted. And we know that if we take that initial point, 1, 0, and rotate it 90 degrees, it's going to end up right there. So the next question is, what is the sine of that rotation? Well, sine, we talked about, is the y coordinate on the unit circle. So the answer here is uno. Next thing. Cosine of negative 180 degrees. So for cosine, we are going to take the x coordinate of the rotation, and for negative 180, we are going to go, let's see, we're going to go counterclockwise. We're going to go this way, negative 180, yeah, right to there. So what are the coordinates of this point right here, we ask? Well, they're negative 1, 0. So I need the x coordinate. The x coordinate of that point is negative 1. So here we are on the next one. I had to do some messing around with my PowerPoint, and I hope I'm leaving off in the right spot here. But a couple more that are kind of like the same thing. This is rotations of multiples of 90 again. So these should be on the easier side. So 630 degrees. But we always start here at 1, 0, which is 0 degrees. We're going to go 90, 180, 270, 360, 450, 540, 630 degrees. So we end up right here. This is our terminal ray for our rotation. That's where we end up if we were rotating this. It would be like, whoa. So we just got to ask ourselves, what are the coordinates down here? Well, they are 0 and -1. And we're looking for the y coordinate because we are looking for the sine. So the sine of 630 degrees is -1. Tangent of 180. Well, the other day we talked about tangent being sine over cosine. Well, we're talking about the unit circle, and we know that, like any random point, I'm just doing a random point here, x, y, is the cosine, or the sine divided by the cosine. We talked about this the other day. In the video called Tangent Theorem. Hopefully you watched that. So we looked at this and we know the radius is 1, and we call this x and we call this y. Well, what's the sine of this rotation, this random rotation that I've done? The sine would be y over 1. So it would just be y. So if I follow that same idea, this is just y. And then what would the cosine be? The cosine would be x over 1. So this would just be y over x. And if I look at that now, isn't this the rise? And isn't this the run of that point? So if we drew just this segment right here, we basically just decided or figured out that tangent is the same thing as, you guessed it, slope. Mind blown. So tangent of -180. Here's how I figure this out. I'll go like this. Start at 0. I go -180 degrees. Whoa. I end up here. The coordinates are -1, 0. Now I could say, all right, tangent of -180 is sine over cosine. So it would be 0 over -1, which is 0. That's our answer. But I don't even do that. I just look at, if this is my terminal ray, what's the slope of that ray? The slope of that ray is 0. So that's it for now. That kind of finishes my basic introduction of the unit circle. I'll be back with some more in a little bit for y'all. Take it easy.